Good morning, everyone. Thank you for being here with us today. I am Fernando Beltran.
I'm Jinken.
From the University of Auckland, I would like to talk about our work on immersive analytics using mixed reality. According to Dwyer, immersive analytics is the use of engaging embodied analysis tools to support data understanding and decision-making. It uses different tools like data visualization, visual analytics, virtual reality, computer graphics, and human-computer interaction in a way that supports data understanding. Its ultimate goal is decision-making, and we make it happen by supporting either individuals or collaborative decision teams. So, what is the problem we study? We want to support more effective and higher quality decision-making in a business environment, one that is very particular specifically. We assume a business team must use a network data set. In our approach, the decision makers must find the most important nodes in a network by appealing to analytical measurements of network centrality. Network centrality is a concept that seeks to measure in different ways the importance of a node in a network. For an explanation of network centrality concepts used in our research, I invite you to look into our paper.
We post that our immersive analytics approach is more effective than using 2D flat screen visualization tools and contributes to higher quality decisions. Besides, it allows for collaboration beyond time and distance.
All right, then what's our plan to solve the problem?
Well, we built Aroaro. Aroaro is a mixed reality multi-user platform. Aroaro supports our immersive analytics approach to business decision-making in 4 basic ways.
Yeah, first, it provides total spatial immersion to business decision makers. Next, it supports a virtualized environment with rich visualization of a network dataset. Third, it provides a collaborative virtual environment. And fourth, it supports both synchronous and asynchronous collaboration.
We believe that the combination of all these opportunities enhances the level of engagement in data-driven decision-making tasks. To achieve this, we conducted lab experiments to investigate the relevant performance of subjects in our immersive analytics facility on one hand, and a traditional 2D data visualization approach on the other.
Let's see how we do it. The figure shows a diagram of components used by Aroaro. First of all, it relies on Unity. It uses the Microsoft Mixed Reality Toolkit to provide client services and Photon that enables interaction among multiple users.
We also use Microsoft Azure Cognitive Services for speech-to-text conversion. 2 more components are PlayFab and Heroku. PlayFab is a backend tool for user management, whereas Heroku is used to host the code that calculates network centrality and other degree-based network properties.
What is network data visualization? First of all, a network is a mathematical representation of the existing relationships, which we call links, between members of a set of entities, which we call nodes. For example, in the context of our research, it models the relationships between individuals, groups, or organizations. We've experienced increasing interest and need in describing business activities and processes, as well as human organizations and business structures as networks. It would then be consequential to support analysis of network with a visualization tool that optimally spaces out nodes and links in the visual scene. Also, we believe it appeals to a higher sense of awareness that analysts are given the ability to fly around over, below, and into the network too. All of this while they access a query-oriented menu, which logically raises the question, can a subject make better decisions in an immersive analytics-supported environment than on a 2D visual platform?
Most relevant questions indeed. Let's say, our testing situation is a fictitious marketing campaign that has access to a network dataset. The dataset contains information about a social network with two types of nodes, influencers and members. The visualization tools are our own Aroaro and commercial tool Giphy. The same network dataset was to be visualized on the two platforms. We had 15 participants. Each participant was asked 12 questions, split into sets of corresponding questions for each platform. We randomly assigned participants into two groups, depending on which visualization tool would be first experienced by a particular subject. The questions in each site were of two types. The first three questions involved low cognitive effort. We call them LCE questions. The remaining three questions demanded high cognitive effort, so we call them HCE.
Subjects were invited to the lab to test our Aroaro interface as well as Giphy. On the screen, you can see pictures of the two visualizations in each platform. A low cognitive effort question asks the subject to name the most important influencer in the network. A high cognitive effort question asks to choose an influencer among a few, normally two, when their values of centrality conflict in the sense that a choice cannot be unambiguously selected. As examples of performance measures, we observe the time the subject takes to provide an answer and the quality of their decision, that is, the quality of the answer provided to a decision problem. You can look at the paper to learn more about our approach to measuring subjects' performance. Let us now use a few samples of the types of experiment results. The chart is a comparison of the time spent on average, providing an answer to each question. The red bars refer to answers given while then the subject is using Aroaro, while the blue bars refer to Giphy.
It's interesting to say how as cognitive effort posted by question increases, subjects in Aroaro takes less time to answer compared to the time it takes them in Giphy. The table on top displays a measure of the answer quality. On average, subjects provide higher quality answers in Aroaro than corresponding answer in Giphy.
The table below displays average answer quality for sets of questions on both Aroaro and Giphy, depending on which platform the subject used first. The top row reports average quality for those subjects who used Aroaro first, for their set of questions in Aroaro on the left, and their set of questions in Giphy on the right. Likewise for Giphy in the bottom row. Finally, let me ask as a matter of conclusion, what can network data visualization do for a decision maker? We are collecting evidence to claim that our Aroaro's network data visualization engine first enhances users' understanding of relations between nodes and links. Second, enhances users' understanding of network connectivity. Third, helps users to discover hidden information and relations. Our results suggest decision makers reach higher quality decisions when facing and resolving high cognitive effort questions in Aroaro. Finally, we expect decision makers overcome cognitive roadblocks in the process of discovering associations, relations, and features of network data. Thank you.
Thank you.